welcome everyone for the new session of the webinar. So we have the pleasure to host today Katrin Millock from Paris School of Economics. And Katrin is an economist really interested by environmental economics. I think that she started her academic career in that particular field, and she's continuing in that field, of course. So Katrin has graduated from Berkeley, and then she moved to Paris. So Katrin is of a Swedish origin, but now I guess that, if I'm not mistaken, she has the double nationality, Swedish and French. And so she came to a literature a couple of years ago by looking at the relationship between climate change and migration. And I think that she started with a nice survey, and then she had also this paper with Ingrid Dahlman on the interstate migration in India and how it was responsive to droughts. And then she produced an additional couple of papers in that particular field. And today she's going to talk about a very interesting question: the role of irrigation in mitigating the relationship between migration and climate change. Climate change captured here by rising temperatures, like Cattaneo and Perry did in their previous paper. So, Katrin, we are very happy to have you on board, and I give you the floor for a 45 minutes presentation. Thank you very much to be with us.
Thank you very much for having invited me. So this paper was started when Théo Benonnier was a student at the Université Cachan. My co-authors then are Théo, Benonnier and Vis Taraz at Smith College. And Vis unfortunately couldn't be here today. We changed the title, and this will become clear a little later. The work is really about long-term migration trends and rising temperatures, the role of irrigation. So as you know, climate change in the form of changing precipitation patterns, rising temperatures, and increased frequency of extreme events, extreme meteorological and climatological events, will affect millions of peoples all around the world. And we have a lot of evidence currently that climate change has affected internal migration, as is well known, from Henderson's work on urbanization on the African continent, and also the work by my colleague Vis with Maggie Liu, who's listening, on urbanization in India. And this has been known since previous papers by Barrios and Strobel on the impact of rainfall and urbanization rates in Africa. So when it comes to internal migration, the picture is fairly clear. And the World Bank issued its well-known report called the Groundswell Report that actually gave predictions for the number of people who would migrate internally by 2050. And they basically gave an interval between 30 to 140 million internal migrants only, from sea level rise and impacts on crop productivity, only those two climate change impacts. But when it comes to international migration, the picture is less conclusive. So obviously here I can only give a few citations to some of the main works on this. So if you take the paper by Michel, Beine and Christopher Parsons from 2015 that uses the same data that we will use, which is the World Bank's migrant stock data, so a proxy for migration at decadal intervals, they find no general effect of temperature or rainfall anomalies on international migration. There are effects on internal migration from natural disasters, for instance, but there is very little conclusive evidence on international migration, which is in sharp contrast with the public debate. So if you look at the newspapers, I don't know how many of you read the New York Times. There's an excellent series by Adam Lustgartner, I think last fall, 3 pieces in the New York Times on climate impacts on farmers in Central America migrating to the US. And there is a lot of press coverage on this. But when you look at the academic literature, very little evidence on rising temperatures or rainfall patterns, changes in rainfall patterns affecting international migration. And this is also clear in some of the reviews I'm citing here, in particular some of the more recent meta-analysis that has been done on the topic. So whereas the academic literature doesn't find any evidence of rising temperatures having a general effect on migration, it does find what has been called conditional effects. And in particular, higher temperatures would decrease international migration rates from poor countries. So this is a stark contrast, right, with the general discourse on climate change introducing or bringing about very huge migration flows, in particular to Europe. And this is an opposite result that's then obviously for migration economists, as you are, is clear. It comes from the liquidity constraint on being able to pay the migration cost. So this is the seminal paper by Katrin and Beine that then finds that in poor countries, rising temperatures will rather constrain migration than increase it. And another paper that is Cachan that I cite here focuses on the agricultural channel. So because climate change, in particular rising temperatures and changes in rainfall, will have impacts on crop productivity, it is clear that countries that are more dependent on agriculture should be more affected, all else equal. And this is what they find. But they work on different data. So what I said so far holds for long-run migration trends as captured by the stock data by Özden et al. And Kai et al, they use the OECD yearly bilateral migration rates. So when you look at yearly, so more high-level frequency data, you do see some effects of either temperature or rainfall anomalies on international migration. But we want to speak to this literature that has emphasized both this, if I may call it so, the poverty trap of rising temperatures and migration, and papers focusing on the agricultural channel. So the agricultural channel is basically this mechanism whereby changes in temperature and rainfall decrease crop productivity and hence agricultural income, and that way would lead people to migrate internationally. So I'm trying to stick only to the papers giving evidence here on international migration, because this is the literature we want to contribute to. So here I cite some of the main papers that have done estimates of a conditional effect on a country being agricultural, where typically then an agricultural country is a country that has a high value added from the agricultural sector as percentage of GDP. But the missing factor, we think, is irrigation. So if we believe that for international migration in particular, there is evidence of an agricultural channel working that explains this increase in international migration rates from rising temperatures, irrigation should be important, and still it has not really been controlled for or introduced in the international migration literature. I will show you some evidence from internal migration studies later on. And for this agricultural mechanism in the temperature migration nexus, for it to matter, I mean, this is pretty clear, because although it represents approximately 20% of harvested land, I mean, this is a bit of an old figure now, I couldn't find an update, it represents 40% of total world food production. So it's clear that irrigated agriculture is important for farmers. It allows them to obtain higher yields and less variability. And the way it works, I mean, people typically tend to think of irrigation as a substitute for rainfall, which is true. I mean, irrigation brings about higher soil moisture around the agricultural crop. But it also brings about a cooling effect on the local weather. So it has a cooling effect. And together, this significantly reduces heat stress in irrigated agriculture. And here I cite some of the studies, and they're not only from the US. There is Welch et al. And Aufhammer studies on irrigation and agriculture in Asia. And this is work on India. So it's important to realize that irrigation not only substitutes for water, but also has this attenuating effect on increases in temperature. So everything that we know about irrigation shows that it is crucial for the agricultural sector, and it should be crucial for climate change impacts. This is clear in the climate change impact literature, but yet it has not been accounted for in the literature on international migration. So this is kind of the gap we wish to, if not fill, but at least do first preliminary analysis of. So this paper is really about a very simple thing, but it raises a lot of complicated issues, and that's why I'm happy to discuss them with you. We basically want to revisit this analysis of migration and rising temperatures on global data and just ask ourselves, how does having access to irrigation modulate the temperature migration relationship? Taking two countries, controlling for what could be different between them, but two countries that are significantly different in their equipment of irrigation. So this is an important point that I'll come back to later on, that we're really looking at access to irrigation as infrastructure. So not the choice of how many acres you'd irrigate, because that obviously is a factor of temperature itself. And the particular papers we want to speak to are the seminar paper that I mentioned by Katrin Millock about the liquidity constraints and the fact that this brings about the contrary to what we read about in the press, namely it should depress migration even more in the really poor countries in the world. Middle income country migration could increase. There's also Gröschel and Steinwach's work on this. And the intuition is clear, right? If you're a richer country, you have sufficient adaptive capital to kind of insulate yourself from rising temperatures or changes in rainfall. If you're a very poor country, you can't even pay the migration cost. And it's the middle income countries where we would expect to see increases in migration following rising temperatures. And for those who have to leave a bit earlier, the preview is basically this, that we find that having access to irrigation at the start of the period we're studying, so we're going to look at the period from 1960 to 2000. And our key variable is basically the irrigation equipment or infrastructure in 1960. And we find that that's complementary to migration, and that the poor countries that typically then would have this kind of migration poverty trap, this is not a totally correct expression, but if you forgive me if I can use that now, they would be less subject to this poverty migration trap with irrigation infrastructure. It's not enough, though, to actually take it away, as we'll see in our results. And we'll do the analysis both on international emigration rates from poor countries, but we also want to look at effects on internal migration, for which we don't have data. So we follow the literature and use the UN urbanization rates as a proxy. And we find a higher cushioning effect of irrigation on the rural-urban migration than on emigration rates. Or at least it's more robust when it comes to affecting internal migration. So a bit quickly now, maybe on the related literature. As you've understood, we want to speak to this literature on liquidity traps and rising temperatures. Basically 3 key papers, in addition to the literature on agriculture and migration, such as the recent Falco et al. Paper. We also want to speak to the literature on trapped populations that was brought to the forefront by Black and Adger and colleagues, but that has been evidenced in these recent meta-studies by Michel and Roman Hoffman recently. And I said that we're looking at international migration data. There are studies who are accounting for the role of irrigation at a country level, but basically controlling for it, mainly as a control. And we found some evidence in my own work with Ingrid Dalman on Indian interstate migration that states that had higher percentage of acreage that was irrigated, displayed a smaller response to drought. Fishman, Jain and Kishore has a very nice study from Gujarat, where they also show some of the effects of having groundwater access, so not directly irrigation, but they show that groundwater access influences whether the sons in the family actually move to the city, so move internally. And there is a small link too with the Blakesley and Fishman recent paper. But it's not really about irrigation, it's more about groundwater access, which is a different measure. And Zaveri, Ren and Fischer-Vanden, they also work on India. They have data on the from the NSS, and it's a cross-section study. So there is some indicative evidence from internal migration studies, but we think that we are the first people really to introduce this question, basically, for the international migration analysis. And one point that I should bring up here maybe is that we will focus, on the temperature results rather than the precipitation. And here we're going to follow the international literature on the climate, weather, and migration nexus. So I should have said this earlier maybe, but the motivation is climate change, right? This big debate. Are we going to see huge increases in migration flows following climate change? But we cannot measure climate change well. Like the studies I've been citing here typically measure rising temperatures, changes in rainfall, which is not climate change. They rely on weather variability. And the two weather factors that are typically incorporated are rainfall and temperature. And most of these studies, and many of them that haven't even had the place to cite here, only find an influence of temperature and not of rainfall. And my take on that is that there is aggregation bias that matters more when you look at international data and country level data, that matters more for rainfall. Because when you speak with climatologists, they would tell you that rainfall needs local regional models to be well predicted. And Beine et al. At the World Bank have a recent paper on aggregation bias, showing that it could indeed be one of the explanations for why these international analyses typically don't find effects of rainfall, but only of rising temperatures. But we're obviously going to control for both, so as not to have omitted variable bias.
Can I ask sorry,
yes.
Can I ask a quick question? Hi. This is really, really want to know the results. I guess the only thing I wanted to ask is whether you thought about crop choice as something, as a variable of this decision in the mechanisms, because of course we could see how irrigation also enables the case of India, which I guess you and I know a bit in terms of working, for example, on 2 seasons. So irrigation, so rain-fed would be the first harvest, and the second you might have, if you have irrigation, you might be able to grow other things that would also have influence on simply on income or on other things that will also matter for migration decisions.
No, you're right. So I haven't brought this up now as an adaptation option, but so we're looking at migration as adaptation. And then obviously there are an entire set of adaptation margins, let's say for farmers, and one of them is crop choice. It could also be more use of fertilizers, potentially pesticides. But the main adaptation margins, I'd say, is crop choice and irrigation. And they are interlinked to some extent. What we then do here is only focus on irrigation infrastructure equipment. What we do then for the weather, though, is that we're going to weight the weather, only take into account the weather during the growing seasons. So we're going to test that for what I'm going to present here in our main tables is basically the growing season of maize. So we're going to look at the crop staples that are most important for the world population when you look at calorie intake. So following Roberts and Schlenker, this is maize, wheat, rice, where we don't have soybeans. But basically, we're thinking that in this context, when we're looking at long-run migration trends and the crop choice, we have robustness checks also for the top crop of a country. but it's fixed, like we're treating that as fixed. And some motivation, I totally agree with you. These are interlinked. This is kind of the next step where I think you need more micro level data. So this is, we want to be a bit humble and just say, we do first take on this, very simple, adding this small factor to the macroeconomic analysis of international migration and rising temperatures. But I'll come back to that question. So our motivation then will be kind of that the main crop you grow is cultural in some sense. Then, of course, there are varieties and there are different kinds of wheat you can grow. But this would be like, wheat in France and teff in Ethiopia, that somehow for each country and culture, there's one kind of traditional crop. And we assume that is the one crop. But this is a very relevant issue. And having microdata and do this, bring the two together would be the next step for me. But this paper is very simple.
Thank you.
Yeah, thanks. But excellent remark, yeah. And I'm sorry not to be able to answer it here, but in the future, hopefully. So the data we're drawing on then, this is data that you all know very well. This is the Östen et al. Data. So it's a proxy for migration. It's the stock data at decadal intervals from 1960 to 2000. So we treat that data following Beine and Parsons' 2015 paper, but then summing up for each country. And then we take the differences. That's our migration proxy. Then for the urbanization rate, we have the UN data. We have the gridded Matsuura and Wilmot data, version 5. This is the University of Delaware data. The main variable, though, that we're bringing that is new, that I will present separately on the next slide, is the area equipped for irrigation. This is also gridded data at the base, from 1900 up to 2005. They basically went back to look at agricultural censuses. So they have taken the FAO data that you can find in Aquastat and the FAO water database, and they filled in the gaps, going back and really searching for sources on irrigation by each country agency. And they also claim that the data quality really only starts to get fair enough around 1960. So this is, we can use it in 1960, so it matches the migration data. In robustness checks later on, because you may be concerned that irrigation equipment in 1960 correlates with other unobserved factors that could explain migration rates, we do robustness checks using two variables. Basically, we're going to control for political freedom or institutions by the revised polity scores. And we're using data also from the World Bank on government final consumption expenditure to control for safety nets. The problem with that data is that it only exists from 2000. So that's why we only include it in robustness checks. But our final sample is 112 poor and middle income countries. And the poor countries here are very poor. So you should think Burkina Faso, Afghanistan, Somalia. India is middle income here, for instance. And you can see the migration rate is what you would expect, 1% approximately in the poor countries, higher in the middle income, almost 2.8. The share of cropland, though, it's around 4%, 3 to 4% among the poor countries, and 13% of this is the percent of cropland that's equipped for irrigation, much higher in the middle income countries. The temperature, poorer countries tend to be warmer, all else equal on average, and have less precipitation. Also lower government expenditure and more autocratic. So this is the revised polity score, so higher numbers are more democratic and lower is less democratic. So we have 28 poor countries and 84 middle income countries. So let me talk a bit about irrigation. This is area equipped for irrigation. So then you may wonder, what is that? What kind of irrigation is this? So basically it's three types of irrigation equipment. It's area that's equipped for full and partial control irrigation. You may wonder what that is. Full control irrigation. This is what you typically think of as irrigation. It's the sprinkler. And it also could include drip irrigation, so very modern forms of irrigation, right, that only more richer countries use. Then it's equipped lowlands irrigation. This includes wetlands irrigation, flood recession and deltas. And there is spate irrigation. This is the historical means of irrigation that human beings have used since 1,000 years, basically, and that is still continuing to exist, particularly in North Africa. These three types are included. The fact that you have access to the equipment, the infrastructure is there, the canals are there. It doesn't include rainwater harvesting. That's important for me because that's typically something that poorer countries could do. You know, you put a tank, you collect the rainwater, but that's not included, to be clear. It's very different from area actually irrigated. We haven't been able to introduce that variable in the analysis because the data for areas that are actually irrigated is much more sketchy. So there are publications by Siebert et al. Where they try to look at this, and typically then the poorer countries would miss that data. So depending on the country, like India has very good statistics on the area that's actually irrigated. But for a lot of other countries that we are concerned with in our sample that are poor, there isn't data on the area that's actually irrigated. And we don't want to use it since it's endogenous with the rising temperatures. You know, what you would actually irrigate in a particular decade should depend on the temperature during that decade. Whereas what you have as equipment, what you potentially could access as irrigation, if temperatures were to rise, that should be fixed. There is some decay, but typically irrigation equipment it's capital intensive, it's long run. And what we then do with this data is we aggregate it up to the country level, and we take this is the geographical crop database HIDE. We take the cropland area and we put it in proportion to the cropland area of each country. So this is how the figures came about, so that you saw the 3% equipped irrigated cropland for poor countries and around 11 to 30% for the middle income countries. So now I can let Martin, yes.
Yeah. I think it's something that maybe I'm getting confused. So should we think of this equipment as unrelated to rainfall or not? Because you said you would be focusing on temperature, but I was thinking at the time that rainfall may influence I don't know, like the decadal of the rivers and the use that you have for these canals and so on, right?
So that's another good remark. So typically then, this would depend on surface water, yes. So from rivers. And we don't find any effect on rainfall. And in a previous version, we did a preliminary step where we used the yearly data on crop revenue that Kai et al. Use to replicate kind of the simple relation between rainfall and temperature and crop yields, and then introduce the interaction term with irrigation. And even there, when it was directly on the crop yields, we didn't see much of an effect of the interaction on rainfall and irrigation. But we didn't see much of an effect either on rainfall and yeah, you'll see later here, rainfall and migration. So this is possible that is because of aggregation, right? This is why we want to make one simple point for the international migration literature. And I think that a lot of the issues then would really necessitate more micro level analysis. But what we also did in a previous version is we did use UN data or FAO data on groundwater resources as a robustness check. Now we changed that specification a bit, but those estimations didn't show an impact of groundwater, or they showed an impact on irrigation. So indeed, I mean, this should be irrigation that's relying on surface water. You have to be close to a river somehow to be able to use it. I mean, historically, this is how this irrigation equipment developed, right? It's near the big rivers like the Yangtze, like the Indus Valley, and this is where it was based, around the Nile.
Yes, Katrin, I have a question about the data about migration. I was wondering how you can deal with potential measurement error concerning international migration that could be more important in poor countries. And we see in the descriptive statistic that international migration are lower than in poor countries than in less poor countries. But I'm wondering if measurement error, particularly concerning migration inside, for instance, in South Africa continent, could be an issue for your result. And the second remark is also concerning measurement of urbanization. I think about the project named Africa Police, who show that what's happened since 20 or more years old. It's the fact that urbanization in Africa is happen not in very little towns, and I suspect that the data gathered by the United Nations about urbanization doesn't take into account these little towns that explain that the increase of these little towns in rural area explains nowadays the main urbanization process that happens, more particularly in Africa.
No, you're
so
right.
How can you deal? How these potential these two potential measurement errors can base or can be an issue for your analysis?
No, you raised two very good points, and we basically follow the literature on international migration and using these proxies. So for the international migration rate measurement error, you're right, this is a proxy, right? You're deducting the two stocks. If you get any change, it's not just migration, it can be death, it can be return migration, this is true. We have country fixed effects, that's all I can say, but yeah, this is a problem, I think that's common for all this international migration analysis. We could do robustness checks with an alternative data set. So now we have the ABEL's 5-year data. That will be another source, right? That's the UN-based data that we could use to do robustness on the international migration rates. And on the second point for internal migration, this is also very true. I mean, this is, I think, also partially what Henderson shows in his paper, that the role of increasing temperatures on urbanization depends on whether the town that people move to is a rural market town or a town with capital intensive industry. And if it's a rural market town, it will also be affected by the droughts. I mean, people wouldn't have interest in moving there. I mean, the urbanization would be driven if they could go somewhere where there would be non-agricultural sector work. And this is true. So, but for international, I'm very happy if anyone can suggest an alternative data. We basically, this is what we use for international proxy for the urbanization rate. This is just to show you, I have to apologize for any people from Greenland who are here. This is basically based on our very bad manipulation of geographical information systems. But the map is only to show you the extent of irrigated cropland equipped for irrigation in 1960 to see the variation. The missing data is basically, you know, the Congo, Mongolia, North Korea, West Sahara, West Sahara. But the empirical strategy, basically what we're going to do is following similar estimations as in Cachan and Piri to show that there is, we expect this term here, the interaction between the poor fixed effect, where poor is being in the lower quartile of the world distribution of income in 1990. Unfortunately, because we don't have data that is for the entire sample in 1960. So we follow a lot of the papers on international migration and rising temperatures and use this. Then we have this triple interaction. So delta 2 here should be negative and delta 3 positive. The triple interaction between being poor, facing higher temperatures, and having, this is the share of irrigated cropland in the country, should attenuate the effect of rising temperatures and migration rates. And we do that controlling for country fixed effects, decade times regional dummies, and poor country dummies interacted with the decade. This I've taken out in this table, the linear country trend. So these are tables now that I'm going to show you that don't have a linear country trend. I want you to focus on these two lines. This is basically the poverty trap that you see here. So if we were to translate that into numbers, so basically how big are these effects? So I said there is a poverty trap, basically liquidity constraint for individuals in poor countries that face higher temperatures to move. 1 degree centigrade increase in temperature is huge. Remember that. I mean, typically this is what we've seen over 2 decades in the past. Typically then, it will be reduced by about 1/3. It doesn't disappear, this poverty trap. Similarly for urbanization, a 1 degree centigrade increase in temperature would reduce the urbanization rate, as it's measured in our data, by around 6.9 percentage points. For poor countries that have a 1 standard deviation higher coverage of irrigation infrastructure, the reduction would only be 4.6. So we see that this attenuating or moderating effect of having access to irrigation equipment reduces the effect by about 1/3. This is the basic take-home message. It's not enough to enable these countries or the individuals in these countries to emigrate. Now I want to make 2 simple points on this estimation. The first one is that we're in the reduced form framework. There are many channels, obviously, that could explain migration following higher temperatures. Conflict, mortality, health, I'm listing them here and giving some key references. We're agnostic about which of these are driving it. The agricultural one was so obvious for me, I didn't even put it here. But in this reduced form framework, where we're relying on identification on decadal averages in temperature, we're really exploiting weather variation, although it's decadal. So in order to get something that could at least approximate climate change and speak a bit more to that literature, we would need 3 decades or less, according to climatologists, to actually measure climate change. And then we know since, in particular, Burke and Emmerich's work, that if we do long differences, so comparing, for instance, the change in the migration rate between 1990 and 2000, compared to the migration rate between 1960 and 1970 and the corresponding temperature changes a decade before, that would more approximate an impact of climate change. This is why we're changing our title. We're really careful saying it's rising temperatures and international migration, the role of irrigation. But to show you, to convince you a bit more, I want to show you we can't do long differences because of the time span. We get too few data points, but I want to show you the decadal differences. So for immigration then, it's not as precisely estimated, okay? But it's there. We see the poverty constraint, I mean the liquidity constraint for poor countries, the decrease in immigration rates, and the attenuating effect of irrigation. And the effect is actually stronger. So we use the mean share of irrigated cropland, that is equipped for irrigation, and the standard deviation in the poor country group to calculate the effect. So here is even bigger. Here the attenuating effect of irrigation would be 56%. So even if it's less precisely estimated, it's stronger. And for urbanization, the effect is robust. So for me, these estimations using the decadal differences, although it's not a long difference, it doesn't proxy climate change, I would believe more in these estimates. And then I just want to show you one more. I want to show you a robustness check. We do these to come back to the question about the crop choice. All the estimations I've shown you are based on weather, aggregated only over the maize growing season. We do robustness checks using weather data over the rice growing season and the wheat growing season. And we also compare with the annual 12-month calendar. When we do that, the results are not as significant, which to me underscores that we are indeed looking at an attenuating effect of irrigation that's capable of reducing this impact. These are the rice results. The poverty trap of temperature migration, the attenuating effect of irrigation, and likewise for urbanization. So for urbanization in general, the results are more significant, maybe because the sample size is larger, because for urbanization rates, we can go back and use the UN data from 1950 already.
There was maybe, are you going to talk about identification, or are you going to talk about the 1960 level of irrigation infrastructure that you are going to use? Or because
we're not going to explain it here. Yes, so maybe we should take that question now then, or afterwards.
Okay,
I don't
because
know.
there was a question of Esteban, and he was talking about the endogeneity of the irrigation infrastructure with respect to income, or with respect to maybe climatic conditions, and also the fact that maybe irrigation might take place in some countries that are less subject to liquidity constraints. So
yes, we are looking at the interaction between the poor country and the irrigation share, the share of cropland. So this will be within group variation, right?
okay.
Yes. So the endogeneity basically then, it depends on what kind of endogeneity we're talking about. I'm not concerned that much with the reverse causality in the sense of remittances being reinvested in irrigation, because we're using the cropland equipped for irrigation in 1960. And we're studying migration from the 1960s onwards. Other sources of endogeneity could be of concern. We were more concerned about potential correlation between irrigation infrastructure and state capacity. I think Esteban's question, if you'd like to clarify, is more about within group heterogeneity, maybe. If there is some endogeneity within the group of poor countries versus middle income. And this, we don't really have any possibility to explore further in our work here.
May I ask a very related question?
Yes.
More about maybe closely related to your state capacity worry. I was worried that if you look at your map of the countries with good irrigation, it may be countries in which you have very strong, long historical links with you had colonies where you had a knowledge that was accumulated. And perhaps these are, it is easier to migrate internationally than for those people native from these countries because of these links with the rich countries or with the potential destination countries.
That's something we could probably explore if we were to use the bilateral data, right? Because then we could control for such links between countries. And so far, we're only exploring the immigration rates.
And perhaps as well, maybe you have lots of, if you could control for more proxies for political climate as well, that would be nice, I believe.
So political climate different from the level of autocracy and democracy?
Yeah, I suppose you have more control for that in some international data sets about the climate, for example, for investors. Just to clean for more possible unobserved factors that might be linked to maybe immigration and.
So for the agriculture channel of migration linked to raising temperatures, we were looking at the papers that really point to safety nets, so government expenditure, mitigating that kind of migration. This is why we choose to try and look for a proxy for government final consumption. We really wanted social security expenditures. The best we could find. If someone can suggest anything else, we're very happy. This is the World Bank data for government final consumption. It's supposed to proxy for these safety nets. That could be an alternative attenuating factor. But it only starts in 2000. So we're very unhappy about that. And that's why we only use it in robustness. Political institutions, we thought were also relevant because of the role they're playing. So for instance, in papers by Doki et al. And Ariu and so on, The jury isn't out of that, I guess, but we do use the same measures in Benson et al. We could add, for sure. I'm not sure why would you add investor climate? Because that's more like total labor productivity channel, maybe. I don't know. Yeah.
Perhaps.
Let's discuss that. Yeah. Which other political or institutional factors will be relevant? I'm very happy to get suggestions. So let me just show you the results with this. So for immigration, this is why I say we have less robust evidence of irrigation acting as an attenuating factor. What's interesting is that the poverty trap doesn't show up. Once you control for both, so let me show, this is in column 2, we control for the government expenditure. That's on its own has no effect. In column 3, we control for polity, which on its own has no impact on the temperature migration relationship. And in column 4, we introduce both. In column 4, then, we no longer see a significant liquidity migration trap. The interaction effect is there. And government expenditure, what is interesting, does have an attenuating effect. But I'm not sure how to interpret it, since the main effect here is not significant. For urbanization, it's somewhat clearer. Government expenditure has no effect on its own, nor has polity on this relation in particular between liquidity constrained countries and their international migration rate and temperature. And the results are robust for irrigation. So this table is the reason why we conclude by saying that we find robust evidence for an attenuating role of irrigation infrastructure on the relationship between rising temperatures and international migration. And internal migration, but less robust evidence for its role for emigration rates. Which bring, yeah, so please, comments on this,
okay.
because...
Okay, Katrin, are you done with the presentation?
I'm done, I can conclude. This is basically our conclusion then, that when we include these institutional controls, the attenuating role of irrigation infrastructure seems weaker for international migration, but it's robust for internal migration, although we know that we have only a proxy. And this paper then leads up to very interesting future research where really irrigation then should be treated as an alternative adaptation margin, and it should be interacted. We have really tried to stay away from that and be very clear that we're not looking here at irrigation as adaptation. We're looking at this as a fixed infrastructure and access for countries that could modulate the migration temperature relationship. Thank you.
Okay, thank you very much for the presentation. So far we have 2 questions that are pending. So there was one question from Esteban and one question from Melanie. So the question of Esteban.
Thank you. This is Esteban. So what I was asking was just a follow-up to what I raised before, and I understand that in a sense there's only so much you can address in terms of the endogeneity, but given that you're really looking at this, let's say this mechanism that is related to liquidity constraint and this kind of macro snapshot of a poverty trap, I was trying to understand better how we might think about the endogeneity of the irrigation stock, and if that's something that would be upward or downward biasing, or in contrast, attenuating, let's say, what we see in migration. And the background for what's going on, and I think it matters both for, let's say, across or within, is that both countries, or even we could think of areas, right, that have better access to irrigation at the start in 1960 may also, right, be better off in other different ways, which would also shape their households' migration decisions.
No, you're right. We should discuss more maybe the expected direction of this bias.
Yeah, certainly I have not read the paper, and that would of course be useful. But if you have a sense now and you can speculate, I would be interested, because yeah, it's just something that, you know, we all know is going on in the background, and it's hard to wrap our heads around it, I think, in an instant.
So basically, I don't want to speculate about it, but what we should maybe do is try and explain irrigation in the 1960s, at least for ourselves, you know, what does it depend on? Because it's not just the development level, it's also geography to some extent. So typically when you look at factors determining irrigation extent, it can be slope of land, proximity to rivers, post-climatic factors. So what we think could be interesting would be to try and explain what happens in 1960. What is explaining these inter-country differences? I think there is a big role for these geographical factors and not only the GDP level as such.
Yeah, no, I would completely agree that to the extent possible, describing, let's say, the determinants of the irrigation stock at that time would be quite helpful for then thinking about what let's say the interpretations are and what the possible let's say directions of bias are.
Okay, Melanie.
Thank you. Yeah, thank you
Esteban.
very much for your suggestions.
Melanie, can you ask your question, please?
Hi. Yes. Hi.
Hello.
So hi, Katrin. Thank you for your presentation. Very interesting project. So me, I had just a questions about like the differences in the results in terms of so the effect of temperature versus precipitation. Because when I see your results, I think that I've seen that when you focus on the months of the rice, of the growing season for rice, precipitation seems to have an effect as important as temperature.
There is an interesting effect there. Yes, I noticed that too, that indeed, when we switch between the crops, there is a small change indeed. For rice, let me yes, that's a robustness check. Sorry, here.
Yeah.
And in particular for internal migration. Yeah. I come to that table. Yeah, this is very interesting. Yeah. Yes, I'll let you.
Yeah, and because I was wondering, because so as I understood, you explained the fact that you do not have effects of precipitation because it's not like climate change is harder to be captured via rains, right? And I was wondering whether it's also just the fact that maybe climate change associated with precipitation happens more like in specific months because maybe rains have more intra-year variability. And that
yes.
maybe, and also, as you said, like that maybe rains shock were more associated to short-term shocks. Could you just check whether you have an effect for short-term rain shocks and whether there is a difference between, according to the irrigation capacities or?
Yeah, so you're right. I mean, when I mentioned that it could be aggregation bias, that's only one general explanation for why rainfall may not show up. And you're right that this is indeed true, that there is more inter-year variability. So thanks for making that point. And then when you ask about the more short-term shocks, are you referring to anomalies maybe? Or because we do try other measures of changes in weather in our estimations that I haven't been able to show here. Are you thinking of anomalies or some other measure?
Yes, exactly. Just because it's true that I understand that temperature changes might be linked also like to irrigation capacities, but I'm just wondering whether like how rains here have an effect. You see what I mean? Like how, what is the role of precipitation there? And if it's really like about the fact that it's just short term and that's why you're not capturing any effect of precipitation changes here. I was just wondering if you had checked for that, for just anomalies or yearly anomalies.
We have tried other weather measures. We have robustness checks with other weather measures, to tell you.
Okay, we have still some time for one very quick question.
Yes,
so I would like Timothy to ask his question about the change in infrastructure over time. Timothy?
Yeah, so thanks a lot. This is super interesting. I was just wondering how the irrigation infrastructure has maybe changed over time, sort of post 1960, since you're using this 1960 measure. And because if sort of countries are kind of in the same ranking over time, and maybe it's improving everywhere at kind of a similar rate, then I'd not be too worried. But if there's like drastic changes in irrigation infrastructure over time, that kind of shifts the ranking around of who has a lot of infrastructure versus not, or if there's some systematic correlation between your initial level and kind of where you end up, I might be a little more worried about how much this is actually capturing the ability to adapt in later periods in particular.
So thank you for your question. I don't have the maps here, so I can basically show you the evolution of irrigation over the decades. And what I think I see is that it's basically in the areas that were already equipped with irrigation that it intensifies. But we should show that formally, I guess, do some analysis to show this. This is my answer is that I'm leaning towards saying that this is really intensifying in the places that already had this irrigation infrastructure, because it's typically historically and culturally determined. So countries like Egypt, Peru have irrigation infrastructure because of historic origins. Yeah, but we should do something more formal to show this. In a previous presentation, I had these maps that kind of shows that it intensifies in the places that already had it in the 60s, but sorry, I can't give more details now. Correlation across decades, I can't give you a figure either. We have to look into that. I agree, these are important points.
Okay, great, thanks a lot.
Okay, Katrin, I'm sorry, but we are running out of time. So this has been the last question. So I think that all the people in the audience who would like to raise further questions could contact you directly.
Please,
so thank you very much for this very interesting presentation. And I leave the last word to Simone. Maybe Simone, you want to add something before calling the day?
I hope to see you online next week. There's a seminar by Murat Kirdar and Slobodan Djajic. I would like to thank Katrin as well. Bye.
Okay, bye-bye. Bye-bye to everyone. Bye-bye.
Bye-bye. Thank you very much.